Welcome to MATLAB tutorials, brought to you by Engineerise.com, where we engineer your rise.
This week we'll start with anonymous functions. These are one-line user-defined functions that are defined without a function file. It can be created by typing a function name, say hyp for hypotenuse, equal to, then @ symbol, within first brackets the input arguments, say a and b. After the first brackets, there's the expression, say square root of a squared plus b squared. Now we can use this function like any built-in function. hyp 3, 4 will return 5. Here 3 and 4 are used as a and b, and the value of the expression is calculated and returned.
There are inline functions also that work quite similarly. The syntax for defining an inline function is function name equals inline within brackets the expression typed as a string within single quotes. If the expression contains more than one variable, like in this case, then the variables must also be mentioned as strings within the brackets. You can see the difference between the anonymous function and inline function in the workspace. Inline functions are outdated and not preferred anymore.
So we have learned about the functions. If we equate it with a value, it is called an equation. Let's learn how to solve a one-variable equation. The first step is to convert the given equation into the standard form, that is, RHS must be 0. Now we can find the zeros of the function on the LHS by using f0 function. The syntax is f0 within brackets the function, then an approximate value. Let's find the solution of this equation. Converting it to standard form, we get this. The function can be typed as a string within single quotes, or we could create an anonymous function for this and put its name as the function. In both cases, we get the same solution. The f0 function calculates the solution nearest to the given approximate value. If the function on LHS is a polynomial, that is, if it is expressed as a sum of different powers of x, then the solution of the equation are called roots of the polynomial. Polynomials in MATLAB are represented by a row vector containing the coefficients of all powers of x, starting with the highest power. So the vector for this polynomial is this. To find its roots, we can use the roots function. Simply roots within brackets the coefficient vector. So far we have been dealing with numerical values and variables that have numerical values assigned to them. However, many applications require symbolic operations like addition of x by 3 and x by 4, that is 7 by 12x, which is exact, instead of 0.5833x, which is approximate without assigning any specific value to x. X here is a symbolic object. To use a variable as a symbolic object, you must define it. Symbs x. Symbolic values can also be assigned to variables. A equals sim5 semicolon, b equals sim7 semicolon. We can create symbolic expressions like p equals a by b. Instead of showing the approximate value, it shows the exact fraction. Compare this with h equals 5 by 7. We can convert p to numerical form using double function. When a numerical value is used in a symbolic expression, it is also treated as symbolic. K equals p plus h gives 10 by 7. Here, the exact value of h was used, although an approximate one was displayed earlier. Let's create a new symbolic expression. Say s equals x to the power 3 plus 5x squared plus 10x minus 30 minus x squared minus 21x. Enter. Notice that the coefficients of same powers have been added to give a simplified expression. MATLAB can be used to factorize expressions or expand them. It uses identities from algebra, exponentials, logarithms, trigonometry, etc. MATLAB can also simplify expressions for you. We can solve equations using the solve command. Here, this is a symbolic expression, since x is defined as a symbolic object. Now, if there is an equal to sign here, then this is no longer an expression. It becomes an equation, and it must be put within single quotes. The answers can be numerical or even symbolic as required. By default, it will be solved for x. If we want to solve for a different variable, we must mention that. It is also possible to solve an expression or an equation without defining its variables as symbolic first. We can also solve a system of equations, but that's a bit complicated. Let's move on to differentiation. The function for differentiating an expression is diff. Within first brackets, first the expression, then the variable with respect to which it is to be differentiated. If we want a higher order differential, you can put the order as another argument. Like to differentiate this 3 times, we can write 3 here. Integration can be carried out by the int command. Quite similar to differentiation, here also, first the expression, then the variable. Notice that no integration constant is added. We can also perform definite integral using this. Say the upper limit is a and lower limit is b. Then they should be mentioned as 2 new arguments within the brackets. The limits may either be numeric or symbolic. It is also possible to solve ordinary differential equations and plot graphs of the symbolic expressions. Now let's say there's a symbolic expression involving symbolic variables and you want to substitute one of the variables with a number. You can do that by using subs function. Within brackets, first the expression, then the variable you want to substitute, and the value you want to substitute it with. This week up to here. Next week we'll learn how to create a graphical user interface and how to plot graphs in MATLAB. Thank you.